All right, this is section 1.6. This is problem 23. It says find the derivative by the limit process. So I kind of wanted to go through some more of those problems because if you have trouble getting the hang of how to plug stuff in, it's going to hurt. If you remember, the derivative is defined as, of a function, the limit as the slope, as the change in the 2 points for the slope that we pick approaches 0. Let me call this an h. I think maybe having a variable here might be easier. I'm going to just write the formula this way. It's f of x plus h minus f of x over h. Your book has change in x in it. Sometimes it has c, but let's just use a h here. That may help a little bit. So what this is telling me here, this kind of gets down to composite functions in a way, or plugging things into that look a little strange into functions. I'm supposed to take the function f, here it is, and instead of plugging in just x, I'm supposed to plug in x plus h. So what that would look like, it would be the limit, I'll write my limit here, as h approaches 0. I'm going to cram that in here because I forgot to write it down before I started writing this problem. It would, instead of x plus 1, it would be x plus h plus 1. And then I'm supposed to subtract f of x here. Well, f of x is just the square root of x plus 1 all over h. Okay, now, this is why I was telling you can't always use your calculator to do some stuff, is if you've got to show your work with the limit process, I don't want just a number here. I need to see the process that you're thinking. What we do here is, since I can't plug h as 0 in, I would have an undefined fraction. I have to find some way to rewrite this function. That's one of the big concepts in calculus. So if you're using your calculator, you're not learning what you're meant to learn in this section so that the rest of the sections will be easier. We don't tend to rely on our calculators in calculus much at all. As a matter of fact, usually we just quit using them at some point during the year like we did with trig. All right, so what I can do here, if I notice I've got these square roots on the top, if I want to get rid of that h in the bottom, one of the things I can do is rationalize the numerator. We're used to rationalizing the denominator because it helps us get rid of radicals in the denominator. But, really that's just a matter of how things look. It's cosmetic. Here, I need to be able to find a limit, and I can't direct substitute here, and I've got a mess here that I can't put on my calculator, so how am I going to get rid of it, okay? Well, what I'm going to do is multiply by the conjugate of the top. You remember the conjugate, if I have something minus something, I take that same something and I add. I'm just taking the two terms and I'm creating basically a difference of two squares pattern by having a plus here. Since I had a minus here, I'll outline it in green, I'm going to have a plus here, and it's the same two terms. If I do something to the top, I got to do it to the bottom, so let me go ahead and rewrite this on the bottom also. All right, now, since I created a difference of two squares problem, you may think you got a lot of simplifying to do there, but you really don't, because what you've got is the first thing squared, so it's x plus h plus 1 squared minus the second thing squared. And the reason that cleans up so quickly is the square root of something squared is just what you've got inside of there, isn't it? Now I got to remember, I got to subtract that x plus 1, so that subtraction sign is going to get distributed to the x and the 1, and you're going to like that it does when you see the results of all this work, okay? Now on the bottom, I'm just going to write what I multiplied by. I'm not going to try to do anything with it. There's not really anything I can do with it right now. As a matter of fact, the reason I want something on the bottom that's not going to be 0, even if it looks like it's a mess right now, okay? So let me recopy it again. Plus 1 plus the square root of x plus 1. Okay. Now, if you look what happens on the top, we're going to get some stuff to cancel out. This is going to be a minus x here when I distribute and a minus 1. And I'm going to go ahead and write it above here just because I know I'm out of room on my iPad and I still got quite a bit of algebra to do. And I'll never remember if I copy it to a new slide. So the x minus x cancels out. The 1 minus 1 cancels out, and I'm left with h over, remember all this still has that limit as h approaches 0 in front of it. I just kind of dropped it off because I'm not having enough room to kind of keep up with stuff on my iPad, so let me just kind of keep copying it. I should do that every time. If I weren't so space restricted, I would do it. Okay, so now if you look at what I've got H, everything canceled out except in the numerator, all that's left is H. Well, if you think about it, you got an H on the top, so that goes in there one time, and the H on the bottom goes in there one time. So what I end up with is 1 over the square root, and again, it's the limit as H approaches 0 of that X plus H plus 1 plus the square root of X plus 1, which is kind of hard to read, so I'm probably going to make mistakes because I can't read my own writing. Now, if I plug in H as 0, because that's what we're trying to do, is get H to go to 0, it doesn't matter so much anymore. That becomes 0, so what am I left with? Now I plugged it in, so I no longer need my limit, all that limit of H approaches 0 anymore, because I just plugged the H in, right? So I have 1 over the square root of X plus 1 plus the square root of X plus 1, I wish that would write, which would be 1 over 2 of those square root of X plus 1s. That is my derivative. It is a function. Your derivative is not going to be a number. It's going to be a function so that you can take any x on the curve, plug it in, and find out what the slope is at that point. This is my derivative, and I did it with this limit process. A lot of people don't like the limit process, but there's a lot of times it might be even easier than the rules for derivatives we're going to get, so we need to know how to do it. All right, if you look at 21, they tell us to find the derivative of it by the limit process. So I'm going to go ahead and do this one also on this video, or at least try to fit it on there. Now, if you remember they just gave me the function, so I had to write that limit as H approaches 0 there. Actually, what I should have done, I shouldn't have written it yet, I guess. That's just my function. I'm going to put y equal here just because I don't want to write the f of x in. It just takes up too much room. I need to say, okay, what I need to do to find the derivative is it is defined as the limit as the 2 points on a secant line move close together. They'll become this tangent line that I can find a slope of, and I have to take whatever the function is and plug in x plus h and then subtract x. You're just subtracting the 2 y values of the points, and then there's a h on the bottom. This is not going to look so pretty, but it's okay. F of x plus h is going to be 1 over, instead of plugging in x, I'm going to plug in x plus h minus 1. Now, I could have put the x plus h in parentheses to show you. Let me put them in a little yellow parentheses. I don't want to really have to rewrite it, but I could have done that because that's really how I have to think to plug that x plus h in. Now I have to subtract f of x, and it's x minus 1, all over h. Now, if you look at this, if we want to try to simplify this, I could get a common denominator. What I'm going to try to do here, I'm just going to play around with an idea that I have that I think might be a little faster. I'm going to multiply by something that will clear those fractions out. And if you remember when you clear a fraction out, you have to multiply by both things that you have in the denominator. So I'm going to need an x plus h plus 1 and an x minus 1. And if I do it to the top, I got to do it to the bottom. I'm trying to clear the fractions out on the top, basically, but I'm still just multiplying by 1 here, so I'm going to do it to both sides. When I do that, that's going to be, okay, if you think about it, if I take this first fraction, I'll kind of circle it in red, and I multiply it by this stuff over here, the x plus h plus 1, I'm sorry, that would be a minus 1, wouldn't it? That should be a minus 1. That should be a minus 1. I just didn't write it down correctly. Those would cancel out, and that would leave me with x minus 1. So I got rid of the fraction there, and I'll use green to kind of do the second fraction so I don't have to rewrite all that. Subtract. Now if I multiply these two things, again, forget that I canceled that x plus h plus 1 out for the first fraction. I'm going to multiply the second fraction by all of it. The x minus 1s would cancel out, and I would be left with minus x plus h plus 1. And on the bottom, I would have h times, let me tell you what, let me write this down. X plus h, that's a minus 1. I keep recopying it wrong. Times x minus 1. And then there's a h there. I'm just going to put the h out here since I forgot to write it down first. So let's distribute on the top and see what we got going on here. That's x minus 1 minus x minus h. Now it will be a plus 1 because I'm subtracting a minus 1 over all that mess. Okay, so let's go see what we got left here before I start rewriting that bottom part. The x's cancel out. The 1's cancel out. I have a negative h over all that mess. So let me write it. Well, let me just say, now all of this becomes a negative h, a minus h. But that minus h, the h part will cancel out with the h on the bottom. Trying to save room on the iPad's all I'm doing by putting a lot of steps in one. So I'd have a negative 1 over x plus h minus 1 times x minus 1. And remember, I have not done any direct substitution, and I should have all along been writing the limit as h approaches 0. Okay? All right. So now I'm not going to get 0 on the denominator. I don't just have an h on the denominator. So what I can do is start plugging it in. So let's plug in h is 0. My top would still be negative 1. My bottom would be x plus 0 minus 1 times x minus 1. Okay? So I end up with a derivative of negative 1 over x minus 1 squared. Remember, my derivative, again, not a number. It is a function so that I can pick any x on the curve and find the slope at that point. The slope is changing at this rate. This is the rate of change that this function is going through. And we're going to find out there's a much easier way to do this in a few chapters. But right now, I don't care if you know the easier way, you must show me when I ask for it, finding the limit process. I have to see it or I'm going to count the problem wrong because I'm asking for your work, not just for the answer. You could get your answer off your calculator even. There are ways to do it. I'm not asking for the answer. I'm asking for the process. Thank you very much.